IT 5303, Intro to Programming with Java, Weeks 1, 2, 3. So we're ending Week 3, and let's do a recap of where we've been and where your head might be in this course. So we started out a course, and we read chapters 1 and 2, and then put together our first Dropbox assignment for our development environment proof of life. And so that assignment, you were to get your tools installed. You learned something about a class path, many of you did, and then you were able to submit the assignment as a PDF. And so let's talk about PDF creation, because PDF creation is not something we teach in the course. It's something that's expected as part of computer literacy. And if you may not have tools, like if you may not have access to the Adobe tools, I provided links on learnomatic.net under the policy section to one particular tool that's very useful, Cute PDF, that will help you in printing PDFs. So once you put together that assignment, we went along to our next assignment, which was our Dropbox. We also had, on a Saturday and a Sunday, we had a GoToMeeting gathering so that students can meet one another, hear one another, and meet me, and then experience an online meeting. We had a real programming assignment, and that was our code assignment 1. And so in that one, you were to submit some code as a draw and submit code as a PDF and as a color syntax printed PDF, not as a screenshot. And then we had our first quiz, and our first quiz was, of course, a whopping 2 questions. So by now that we've ended the second week, you've experienced those things that you'll need to do in an online course, and that is communicate online. We're using Piazza, and so you can communicate with your fellow students that way. GoToMeeting. Hopefully you have met individually with another, perhaps using Skype or Google Hangout works very well. And then you have used a D2L Dropbox, and you have used a D2L quiz. And of course, you've created your PDFs. So those are the main components of how you'll turn in assignments in this online course. Later on, we may do some audio and some video, and so those again are some basic computer literacy things that are expected. So if you don't know how to do, for instance, a screenshot, which everybody, pretty much does, or how to create a video of, could be you talking, or specifically a video of your screen, you should take a look at a tool. It's free, from TechSmith, which is Jing, J-I-N-G, and you should be able to create an audio, and specifically an MP3 audio. And if you need a tool on your computer, take a look at Audacity. I have I believe a link on my Learnomatic site. And of course, you can always use your cell phone to record and then bring into your computer. And again, my preferred format is an MP3, and for video, it's an MP4. So moving on to week 3, now we're getting into some meaty Java stuff. We're going to begin talking about the language. We'll talk about how to use JGraphs at a level higher than, okay, I opened a file, I compiled it. We're going to talk about debugging, and then we're going to have another coding assignment. So by this period, you should be settling down into the course and losing some anxiety that you may have had in the beginning, and now are ready to really attack what is programming. So what if you're feeling a little overwhelmed? What do you do? Okay, is this your first semester at Southern Poly? And um, you might not think it as an adult. You might think you're past this, but certainly I have found that the adults who are beginning graduate school, they're very nervous and they're very scared to do something that might not be perfect. And if you were perfect, then I don't know why you would be here, because you already knew the material, right? So you wouldn't have a need for this. I can share that I'm teaching myself how to sew, and I like to watch craftsy.com videos. And I've watched lots of videos, but when I go to my own sewing machine, I am exceedingly imperfect. But I just tell myself I'll get better over time. And of course, in my head, I don't say I give myself a grade, but I certainly go through and say, oh man, my darts were good, but my neck binding, ugh, not so much. I'll do better next time. And maybe what materials do I need in order to do a better neck binding? So for you, what materials or information do you need to do a better job? Some of the students online mention different videos from different sources. And so, yes, lynda.com has some good programming videos. Some of the students are struggling with computer proficiency. So when they did the first assignments to develop proof of life, what is a command prompt? What is a class path? And so those fit where, again, a computer proficiency. So there are resources for you to go online and find that, or maybe ask for some help. And if you didn't know what that was in terms of your personal computer, and of course you're on a Mac, you'd have essentially a Unix terminal, and you'd do the same thing, but you'd need to know the various Unix commands. So if that's something that's missing, then maybe you need to go find some books in order to build that proficiency for you. Some other students are having trouble with media creation, specifically the PDFs. And again, there's lots of resources online. It'll just take you a little longer to go find these things. I cannot stress how important it is to find other students in your graduate program who are working on the same things that you are. One, they're very interested in what you're doing, and you're interested in what they're doing. Also, they will help you, and you will help them fill in the gaps that are missing. So I went through a course on Photoshop, and I am not a photographer, and I'm very color challenged, but I had a partner who had been a military photographer, and so she could help me fill in the gaps. And when we got into programming things, I'm the expert, she's not, and I was able to help her out. And we swear, pinky swear, we wouldn't have gotten through graduate school without each other. And so hopefully you can find someone that's a good complement for you. Sometimes when I have students who English is their second language, I say, you really need to find a native English speaker in order to help you proof some of your assignments, and just do some light proofing on grammar construction. You'll come across much better to the instructor. So maybe your life is overwhelming, and maybe this is just not the right time. I've had students contact me of they're going through a divorce, or they've gotten a brand new job, and so maybe you don't give up that dream, you just put it on hold for a little while longer. Is this the right course for you? There are some transitional courses, IT 5301, 5302, that are on different subjects. So one is Introduction to Hardware and Software, and I strongly recommend that course as a first course because it dives into data types of ints, and it talks about bits and bytes and assembly code. So that's a really good one to jump into, so you might want to pause and go there. You also might want to take the Intro to Web Programming instead of Intro to Java Programming if you're more familiar with web tools, for instance. And of course, we've all used HTML as consumers and CSS and JavaScript. But again, these are courses that are programming courses, and it may just be that you have to put a different hat on and think a different way. All right, so as long as that's been said, take a breath, breathe, and just try. As my mother would say, you just try again. Chapter 1 in our DITA book is very broad and should be familiar. We're not going to test you over some of the lots of terms and machine languages, but you should be familiar and have read these sections. So you'll learn that Java is an object-oriented programming language. And so that's very different from a procedural language. And so procedural language you can think about is very linear. It has a begin, it goes through lots of steps, and it has an end. It may have subroutines. So I go here, okay, I can do a subroutine, which is a very linear process, and I come back. The way that object-oriented programming languages are constructed is very different. You could think about an object or a class is a collection of methods that deal with how to do something with that class. And then there's data that's associated particularly with that class. And so they're all related together. And then we have other objects or classes that can integrate or talk to one another. So it's rather nonlinear. It takes a little bit to get your head wrapped around how it works. But also, if you start off with object-oriented programming, you'll find that procedural programming is nothing in comparison. It's kind of like learning how to drive on a stick shift. Once you drive on a stick shift, then driving an automatic, piffle, it's nothing here. So there are a couple of different editions of Java. So there's SE, EE, and ME. We're using SE, which is the standard edition. EE is for enterprise, and ME is for devices. Or the micro edition. Java can run on many different platforms. And that's actually the beauty of Java, that the JVM, the Java Virtual Machine, gives us this almost like a computer that the Java language talks to. And as long as you can get a JVM on that particular piece of hardware, you can run Java in that environment. And so there are portable devices, not this one, but portable devices that know how to use Java. Obviously Android is an example because Android is Java, and so Android, again, this is not an Android, but there's all kinds of different underlying hardware, and because of the Java Virtual Machine, you can talk to this hardware and you can talk to my Mac that I'm using the same programming language. So we're going to skip here some of these different projects, although I happen to have bought one of those OLPC, one laptops per child, years ago. And this is something here, these sections you probably would have gotten if you've taken the IT 5200, which is the Introduction to Platforms. And that class will talk to you about some of these concepts here, but we'll go through them very, very briefly. So here in the beginning, a computer is a device that can perform computations and make logical decisions phenomenally faster than human beings can. That's really, in essence, what a computer does. And so we have to tell it what to do, and that's programming. And so we're providing a set of instructions to a computer. And so when we do that, we use a programming language. All right, so a computer is its hardware. For instance, it's your peripheral devices like your keyboard, the camera that I'm using, hard disk, but at the heart of it is this thing called a CPU, or Central Processing Unit, and that is really the brain of the computer. And so these computer chips, or microprocessors, they can be embedded not just in a computer, but they can be embedded in a car, again, a smartphone. They're everywhere, in children's toys. Moore's Law here says that, you know what, it's just going to keep compounding and compounding. So this section on data hierarchy is something you would get, again, out of IT 5200, so we'll just gloss over it very quickly. It's something that is nice but not necessary for this course. So here we have what they're calling a record, and so a record may be something that's loaded into memory, or it's an individual entry in a file. So we have a person, so Judy Green is in this file, and so a file could be like a Word document, or it could be things of a relational database. Everything in a computer, if it's stored on hard disk, is stored in something we call a file. And so a file contains bits, and those bits have meaning. And so here we're going through our zeros and our ones, and so these bits are translated here into characters, and then characters build up strings that build up sentences. So computers have input, they have output, and they have memory. And so when we run a computer program, it is resident memory. So it's loaded from your hard drive. That's where the .class file or the .jar file, which contains many .class files, that is loaded into memory by the Java virtual machine, and then that program has a series of instructions, and those instructions here are machine language. Now, we thankfully, do not have to write in machine language that looks like that. Or this right here in particular. This would be assembler. And so we want to write at a much higher level. So we want to write at a level like this, where gross pay equals base pay plus overtime. So that's where computer languages come in, and one of the reasons why there's such a plethora of languages, because they can express varying levels of concepts. So older languages like COBOL and Fortran, those were very procedural languages. COBOL is more for business, very record-oriented, file, data. Fortran was used more for scientific. It had lots of libraries for calculation. And then if you're doing web type manipulation, then that's where something like JavaScript and PHP comes in. And there are languages for artificial intelligence. So that's what a language does. It allows you to be expressive. I think there's a kind of old wives' tale about Eskimos and their language of how there's, I think, 31 ways of talking about snow. And you can imagine if you had lots of snow around, you'd have lots of ways to talk about snow. All right, moving on to object technology. So this chapter right here, this 1.6, you really want to read this one probably several times. So it's making an analogy of the automobile as an object, your methods and classes, and instantiation. So a class is a template. That's your .class file, right? You wrote a .java file that's translated to a .class file. And so that's your template of what you're telling the program to do. The object is the instantiation of that class. The object is sitting in memory, and it says, oh, I'm one of these classes. I'm an automobile class, so I'm going to know how to be constructed, and that's a constructor, how to initialize myself, and I have certain methods like drive or park or add passenger. And so that's my object. The method would be, say, add passenger. Instantiation is where you build one of these objects into memory. Reuse is hugely important in programming languages because you're going to be doing the same thing over and over again, and you want to not have to specify those instructions. So you may have something like a loop, or you have, I do this over and over again. Let me just make a method that adds a passenger, because I have to go and have some code that says open door, make sure the seat is empty, let the passenger get in. Are they going to use the running boards? Yes or no? And so I don't want to repeat that every time that I have to load in a passenger. I just want a little routine that does that for me. So when you begin constructing your software applications, reuse is going to be in the back of your mind. It's something that you'll mature into over time. So messaging and method calls. So when you call a method on an object, that's really you saying, hey, I want you to go do something. That's a way of sending it a message. And attributes and instance variables. So again, back to this car. Well, a car has number of seats and it has number of passengers that are loaded. So those are the attributes. How many doors does the car have? And so there's represented by what are called instance variables. And you're also going to learn about what we call getters and setters. So we often hide the implementation of what happens in that object from other objects. So if I store the number of doors as an integer, then, or it could be a floating point number, it really should not matter to the outside program how I store this. The outside program will say, hey, give me the number of doors. Encapsulation is also a key idea. So back to that information hiding and encapsulation, so that's part of the reason we have scoping, where you'll see attributes like public or private. So I want the class to know how to do things with itself, say within its family, but I don't need, other things don't need to know about it. So for example, how to crank the engine is private to every particular kind of car, whether you have a key fob, you have a fingerprint, or you have an old-fashioned key like I do, or it doesn't matter how it's implemented, because the person, say there's a person class, a person object who's going to crank the car, then all they know is they say, well, crank the car. That's all I need to know. Inheritance, we'll cover that a little later, is also a good concept, because maybe I have different kinds of cars or different kinds of automobiles. So I have a motorcycle, and I have a truck, and I have a car. And so we look at object hierarchies to see, well, what's the same and what's different, and where can I put these kinds of functionality or these pieces of code so that I don't have to write more of it and it's more easily maintained. The act of thinking about and planning your program is object-oriented analysis and design, and it's a huge area. And one of the things that we're going to use in class is UML, Unified Modeling Language. And your JGraphs tool has a UML visualization tool built in. That's one of the reasons why it's really good for students to use. Because once you get these different classes talking to another, after a while you really need a picture of what all's going on. And if you want to share your code with someone else, a picture really helps. So there's a brief overview of some of the main terminology that we're using in Chapter 1. You are probably using either the Windows or Mac operating system, but underneath the Mac operating system is a Unix operating system, and Unix is what's used on most production platforms. Now we have mobile operating systems like Android, and that uses Java as well. Here's a great list of programming languages, and so take a look at COBOL and Fortran. These predate Java, and so they are not object-based. Later programming language like PHP is object-based, kind of loosely. There's lots of different definitions. JavaScript as well, and the more recent languages like Ruby on Rails and Scala, those are kind of interesting too. You might want to read about those independently. So you have installed your Java development environment, and you're going to use some of the class libraries that are provided with the language. And so systemout.println is an example of something that's provided by the language. And so you really want to use what's there in the language versus writing your own. And those are called Java APIs, or Application Programming Interfaces. And if you go out on the web, this may give you a new view of something. Say go to Twitter and look at developer.twitter.com or developer.linkedin.com. Those web systems provide a set of APIs, Application Programming Interfaces, so that you can work with those systems at a programmer's level, not just at a user's level while I go use Twitter, but at a programmer's level so that I can programmatically manipulate Twitter. Here's a very nice picture of creating a program. So you have an editor. Your files are going to be stored on disk. You can use a variety of different editors, but we're going to use our JGraphs editor. You're going to compile the program, and so JGraphs does this for you, but javac is the command line, and if you were trying to verify that you had your tools installed, you would probably go run javac to make sure that that was there. Javac is the program that is the compiler. And so welcome.java is that text file. When you run the program, then this is where your class file is loaded by a class loader, and it's loaded into memory. and this bytecode verifier is to make sure that there's nothing been manipulated or changed about the program. And then the JVM, this is the Java Virtual Machine, that's the piece that keeps you encapsulated from the particular piece of hardware. That's the write once, run anywhere piece. And so it's the JVM that goes and loads your program and executes your program. So you've already seen when you execute your program that sometimes things don't go right. So you have runtime errors that can happen, and you'll learn more about those later. So let's say that you're now ready to run your application. So you'll need to get to a command prompt here, and if this is something that you don't know what that is, then that's that basic computer literacy where you'll need to go find out what is a command prompt. And you may set a learning task for yourself to say, well, what other things can I do from a command prompt? You can go look at your files. You can create a batch program, a little batch file to go and do some tasks for you. It can copy files. So that's the way that people used to interact with the computer before there was a GUI, a graphical user interface. And so here's an example of your command prompt. And usually it'll tell you what your current path is in, what directory you're in. And you run the application. So here they've got Java and then the name of the application or the class file. The application here is going to accept some input. And so in your first programming task, you've already accepted input from the user with the scanner class. And you can interact with the program. The program is running in memory. It's giving here in this example a text interface, and so you know that these are systemout.printlns after your first programming, and then you can close the program. We're going to skip the Web 2.0 going social. How very interesting, but not really relevant. You want to take a look at some of the agile software development. We're going to use this later on, especially for our project. This is how we're going to manage our projects. And these terms are good to know, but not necessarily really relevant now, like refactoring and design patterns, LAMP, and software as a service. But certainly as an IT graduate student, you should know what these terms mean, and you'll really learn more about them later on in your program. And that's the end of Chapter 1. So Chapter 1 is very broad, but it gives you an overview of where you're going. Now let's move on to Chapter 2. So in Chapter 2, our first program that we're going to take a look at here is essentially Hello World, or our Welcome to the World. So you can notice here that there are some comments at the top, and those are done with a // The numbers down the side do not appear in your code, but they appear in the editor, and so it tells us which line number, so you can refer to line number 7. And line number is important when you go to digest errors, because they'll tell you where the errors are. So you see this here, public static void main string args. This is a very special statement. You generally won't have a declaration like this in any other method other than your main method. The main method is the starting point of your program. It's where the Java class loader, or excuse me, the JVM knows to begin. So in your manifest file, which should be created for you automatically in JGraphs as you go through the wizard, you'll tell it which class will have this main method. So breaking this apart, public means that this method is visible outside of this class. Well, right now we only have one class, so that's okay. But if there were other classes, then other classes could see this method called main. Static is a bit of an advanced concept, but essentially it means you don't have to have an object of type welcome to use this class. So you can use call main without having instantiated a welcome class. And like I said, that's a bit of an advanced concept, but we'll get to it later. Void means that it doesn't return anything. And returning values is very key when it comes to calling a function. Let's say that calculates two numbers, and then it's going to return back the result. Main is a special word in here, main, and then in the parentheses, well, that's our arguments. Those are the parameters that are passed to the main. And where you see string, so that means text, brackets is an array, and then args is the name of the variable that you would reference inside of main. And so the brackets here, string brackets, means that there could be any number of arguments, not just 1, 2, or 3, it could be 10. And when you execute a command line program, one of the things you'll do is you'll give it arguments. Matter of fact, when you say java-jar, name of your jar, -jar is one of the arguments, and the name of the jar is the value that that argument is expecting. So actually 2 arguments are passed to the main program of Java. So here our author talks about adding comments. I really want you to add your name, the date, and then something about the program here at the top. And this is really key when your programs get bigger, you don't know when you last touched something, or also when you don't have good version control. You've got a couple different copies of this class, and you're not sure which one is the latest one. Well, if you modify the date at the top and usually keep even a changelog, you'll have an idea about which one is the right one. So our author tells us about, we have // comments, we have /*, *// and then there are Java comments, which are /*, and then // or asterisk. Blank lines are inexpensive and they add for good readability. And so here our author goes into class names and identifiers. Identifiers are variable names. They're the keywords that you are defining. And so there's, like we had here, this public keyword. As a matter of fact, in your textbook, there is a list of keywords. And those keywords are in Appendix C in your book. It's around, it's in around page 1368. So keywords are, let's go take a look at those. So those are in Appendix C. So, abstract refers to a type of a class, meaning that this class cannot be directly instantiated. Case is a switch statement. Default, extends. Extends is where one class inherits from another. If is a conditional. Interface also deals, again, like with extends and abstract. An interface says, I'm going to fulfill this contract. Private is sort of the opposite of public. Static is a modifier that has to do with when a method can be used, whether you have an object or you just have the class definition. This is used inside of a method to refer to information for this class. Void is, as it's nothing, like a return type of void says don't return anything. Assert we won't use. Catch, try and catch, deals with error exception. Do while, is looping. Final has to do with, again, kind of like in that static category. Implements, again, with extends and interface. Long is a variable type. Protected goes along with private and public. We'll skip strict FP. Throw, as in throw catch, is exceptions. Volatile, we'll skip. Boolean is a type, as in car and double. Finally is a try, catch, finally. Import, we use that one because we need to tell Java where to find certain classes. Native, we won't use. That deals with capabilities that are native to a particular platform. Public is along with protected and private. Super means the referencing a method that's in the ancestor class. Throws is in throw, catch, final, or throw and catch exceptions. While, do while is part of our loop. break. If I have a case statement, then I can break out of that statement as I go through the cases. Class, well, that's our basic class definition. Else, if, then else. Float is a variable type. Instance of is actually, are you an instance of this kind of class or that kind of class? Probably not used much in our case. New means to go allocate a new object of a particular class type. Return says, okay, I'm at the end of the method and I'm going to return either nothing or I'm going to return, say, an integer. Switch is our case statement. So based upon whether a value is 1, 2, or 3, execute the code here under this block of here's code for 1 and code for 2. That one makes more sense when you see it. Transient we won't use. Byte is a variable as a data type. Continue goes along with a switch statement. Enum, those are fun. That's a way that you can have a set of things. Instead of saying 0, 1, 2, 3, 4, 5, I can say apple, orange, banana, and grapefruit, and they map back to 0, 1, 2, 3, 4, 5, but we get to use some descriptive names for those things. For is in our for loop. Int is a type. Package, that goes along with our class, and so a package is a collection of classes. Short is another variable type. Synchronize we won't use, that deals with multi-threading, and try goes along with a try catch. You'll never ever in our class use goto, and you probably will not use the word const anyway, which is not used in Java, but it is a reserved word, and so you cannot name a variable any of these things. Alright, and so moving back through Chapter 2, we can see that we have some rules about a left brace, or we call them curly braces, and that goes out like that, begins the body of every class declaration. Almost everything is surrounded by curly braces. So a if, then, else is going to have curly braces. Those define programming blocks. Parentheses, which are, of course, your normal parentheses in punctuation, those will define, say, order of operations. Square brackets will be, for instance, indexes of arrays. So here we declare a method, public static void main string args. And now on line 9, we're going to use one of the Java APIs, and that is system. System.out.println. And so system refers, if you wanted to go look this up, let's go do that. Let's go look in the Java doc. So here I'm at docs.oracle.com, Java SE 7 docs API. Almost if you go Google, you'll find somebody has the Java doc available. Java docs are documentation that is generated from special information in your header. And so although someone wrote this, this is not an HTML document that someone put together. This is generated from the source code. And so there's this concept called self-documenting code. All right, so let's go look at the various packages. We have applet, AWT, there's a whole list of them. And so we want to go look at the system. So we need to figure out what package it's in. So I can look and say, oh, well, is it in the util up in here? It's definitely not in the Java X's. And is it in the lang? Ooh, I'm not certain. So if you're not certain you can find it, then of course there's always Google to help. So if I look for Java API system.out, let's see if we can figure out what package this is in. It's in java.lang and the class is system. So I could reference java.lang.system if I wanted to, but I didn't have to put that preference on it. I didn't have to do what's called a fully qualified, qualified with the package name and the class name. So let's look at this Java doc briefly. And a descendant of Java Lang object. Now you're going to find that everywhere. Almost everything in Java is a descendant of that particular class. That's not terribly meaningful. It has three fields, air, in, and out, and it has these methods: console, exit, garbage collection, get environment variables, get properties, identity, load, and somewhere out here we should have something that has meaning for us. Let's go back out here and look at this print stream, our dot out. And so this is a print stream. And so a print stream has a println function. And so let's go look at this print stream. You can see how all this stuff is hyperlinked, so it's very easy to go from one class to another. All right, so a print stream is a descendant of a filtered output stream, an output stream, and then an object. Well, very interesting. And this will tell us a little bit about what it does. And so one of the reasons you want to know the what it's a descendant of, because it says add functionality to another output stream. And so I might have to go look at output stream, for instance, to figure out exactly what this class does. And so by looking at these things, this is where you'll get a feeling of where inheritance is used. And of course, we're going to be talking about inheritance all semester long. And here we can find the various functions. So it can do append, close, flush. And here's our print, all kinds of prints. Now notice that we've got lots of the method prints, but the arguments that it takes are different. This is called operation overloading, and we'll be talking about that later. And so we have a print and passing it a string, and here we have a printf. And so printf, you can see, takes a variable number of arguments, and that's what this little ... operator is all about. But println does not. Println, you just pass it the thing you want it to print. But printf is where we can do these neat character substitutions. Alright, so we'll pop back over into Chapter 2. And so that's a little more than you wanted to know about system outs. Maybe it'll help it be less mysterious and give you some ideas about where you could go next in your investigation of a programming language. And so we end with a curly brace. So once you have this program, you're going to compile and execute it. So the compilation stage takes your ASCII characters, your .java file, and changes it into bytecode that is readable and runnable by the Java virtual machine. And this bytecode is in your .class file. So let's go take a look at a .class file and a .java file. So here's my JGraphs directory, and I have a carolgreetings.class and a carolgreetings.java. So if I go and I'm just going to say open this with my favorite text editor, Text Wrangler, I can see, all right, this is about as small a program as you can get. And my program will not run from the command line because I don't have a main. I just have a hello Carol method. But let's go take a look at the .class file. And we'll open it for now with a text editor. And this doesn't quite look right. We can see some stuff in here. So we can see my Carol greetings, hello Carol, source file. We can see some object types, but this doesn't look like anything that we would manipulate. And certainly if I were to change a character or write it, Java would not know what to do with it. It wouldn't pass the what's called a bytecode verifier. But let's go open this up in a different kind of editor. Now I have this class file opened in a hex editor, hexadecimal. And so if you've been through IT 5200, which is the Introduction to Platforms, Hardware, and Software, you'll know about binary and hexadecimal. If not, that's okay. And here's a little private Java joke. The first characters happen to be Cafe Babe. So we can see that it looks like this if they're translated to ASCII, but this is the hex characters. And so now if we look at the program in this way, these are going to correspond to program statements that the Java virtual machine can understand. And if you care to know what editor that was for a Mac, that was called HexFiend. So the author goes to give us examples of how from the command line we can compile our program. Now we're going to use JGraphs, and so it's going to help us with an awful lot of this sort of thing. So we'll just move on. So once you have your program, you want to make some changes. And the easiest change to make is just change what text that it prints out. And so there's a common joke in programming. The very first thing that you write we call hello world, and this is our version of it. So we want the program to come back and write to the console and say, hi, yeah, I made those changes. And that's the first thing that you do when you make a program do something for you. Is at this point it doesn't even have input, it's just going to give us some output. So the author goes on to explain how we can make it print on multiple lines. And so this escape character N is the way that it's doing that. And let's go look at what these escape characters mean. We're going to go back to the appendix and we're going to look at Appendix B. And that is the ASCII chart. So these are the characters in the ASCII character set. And a 00 of hex 00 is null. And oddly enough, there's one for bell. It makes a dingy noise. This is in the old console apps, very command line, green screens kind of stuff. And then you can see how there are all the alphabetic characters as well as the various punctuations. And so here the author gives a brief explanation about what this means. You should probably go look also up the Unicode character set as well. Here's an example where Wikipedia has a better table than our author does. So here's the binary value. We don't care about octal, decimal, and hexadecimal. So decimal here is 0, or a space is a decimal. Let's see, it should be 32 is a space. And if we look here to get our explanation of \n or \r, so right here is a line feed, and it is telling the program that's interpreting the output, I have ASCII character, A, B, C, D, and then when I get the ASCII character 10, and think about old-time printers, then now it's time to do a line feed and start at the beginning of the line, and I can go A, B, C, D in a new line. Now, going back to our program, get on the right page here. We modified our program, and we are now displaying multiple lines of text. And here our author gives us some more characters, so /T to move a tab over a certain number of spaces. And if you actually want to print a backslash, it's \\. And because the text that we want to print out is in double quotes, if we were to put double quotes inside, then the parser wouldn't know what to do. So we actually embed double quotes inside with a /double quote. So system out and then println in quotes. That's a really good test question, I would think. So we'll move along. And now we're going to display some output with printf. Well, I already showed you how if you go to system out dot, you can see .println and printf. Those are actually two separate functions. And so the F means formatted. And so what you can do is you have these percents that can do some character substitutions. And so when you say welcome %s, that's the first string, /n would be new line, %s is the second string, and then /n is a new line. And so we get welcome to new line Java programming. Commas are very important. Punctuation is just as important in programming as it is in language, although the compiler will not let you get by without the proper punctuation. So we've already seen that we're going to use curly braces around block statements, and we're going to use commas in between arguments to methods. So now we're going to enhance our application, and we've got a whole bunch of stuff we're adding here. We've got this scanner, so that's a new class, but we know how to go look it up now. We can go to java.util.scanner. That import statement says, hey, go find that class for me and let me use it somehow. So if we go Google Java util scanner, we can go do that. All right, so the Java doc has given us a little bit of information here. A simple text scanner which can parse primitive types and strings using regular expressions. All right, so you need to know what is a regular expression and what is a primitive type and maybe what is parsing. So they've given us an example. So scanner equals new scanner system in. All right, well, scanner is the type. SC is the variable name. That's what you completely make up. Equals. And then this is where we're going to allocate some memory. So new is one of our keywords that we go and we're going to say, I'm going to create a new object. And the class type is scanner. And generally, this class here and this class here need to meet unless you're casting variables, and that's more advanced concept. And system.in is something that I'm passing to the scanner object, and this is a constructor. So I'm passing system into the constructor. And here we know how to go look at system.in because we looked at our system.out. So system.out is the console, then system.in is probably the opposite. It's the magic way that characters come into our program. And so int is one of our primitive types. It's a number, like 1, 2, 3, 4, 5. And I, for whatever reason, software developers pick I as the most common meaningless variable name. It's innocuous. I itself doesn't have a meaning, but for whatever reason, developers pick that as a good starting point. So I equals, and then SC, well, that's our scanner object. And that scanner object is going to have a method next int. And so it says, oh, I'm going to wait here, and you've told me I'm going to get some input, and now I want to read the next integer of that input and stick it into this piece of memory for this int. All right, and so we can read more about the various methods that are available to us, and lots of detail. Here we go. So scanner created, these are constructors with a file or an input stream. And here we have delimiters. So returns the pattern the scanner is usually using to match delimiters. So I might need to know what a delimiter is. Usually that would be like a comma or semicolon. It might be a space. And what are we going to use to separate various pieces of input? So by looking at these Java docs, you can learn more about the methods that you're using. So let's go back to our original piece here. Not that. Here we go. Alrighty, so now I have a class addition. So the class name changed. And we have a scanner input, we have a couple of numbers, And now we're going to output, give me your first integer, and we're going to sit here and we're going to wait until we get a number. What happens if we give it a character string? It's probably going to explode all over us. But we'll go down the happy path right now, and we'll just give it the input that we believe that it expects. Alrighty, so our author goes to explain all these things that I just discussed. And when you compile it, output it, you will have a working program that will know how to accept some numbers and output that. Now, here's the heart about a computer program. This computer can add these numbers all day long. You start asking me to add numbers all day long, I get really confused after maybe the 50th one. Computers don't get tired of adding numbers. And so this gets to the dynamic nature of a computer program. It takes input from the user, it takes input from files out on the web, mashes it together, and it does something with it. And here our author is saying, hey, yeah, go over and look at the Java docs. Go take a look. Don't be scared. Now author goes into memory concepts. So somewhere our program is loaded into the volatile memory of our computer. And when we say like int number 1, what we're telling the computer to do is reserve a little spot of memory for this number 1 value. You're going to read something in here and you're going to shove it in there. If you've been through, I know I keep mentioning it, the introduction to platforms, we do a simulation called Little Man. And we really break down into some very detailed concepts what that means to reserve a piece of memory. We talk about chipsets and the whole bit. So here our author is giving us the same kind of detail where we have a variable location for number 1 and number 2. And they have 2 different numbers stored in there, 45 and 72. And then we can add those numbers and put it in a third variable called sum. Which leads us to arithmetic operations. This is like the first manipulation that you'll do. You probably want to go and look at the index for orders of operation and precedence, which is in the back of our book. There we go. And so this is going to go through the various types of operators. And I don't know if you remember from grade school, my dear Aunt Sally, multiplication, division, addition, subtraction, and then when you have parentheses around things, those have different meanings if you have parentheses around these 2 numbers versus these 2 numbers in an equation. And so this operator precedence chart will help you understand when things are evaluated. So generally from left to right, but some here are right to left. And it's also a good place to look at all the different, again, operators that you might not normally see in the beginning, but you're going to see them later on. So plus plus is a neat operator because it's called a unary postfix increment. And what it does, it just adds 1 to a number. So instead of having to say I equals I plus 1, you can just simply say I plus plus. Or you can do plus plus I. And those are 2 different things because depending on when the plus plus is evaluated might change the way that the computer computes an equation, for instance. In your sample program, you will use the division as well as the remainder. You probably won't use shifting, like shifting left and right of bits. And of course you'll use, plus equals minus. But you'll also probably use the conditional and conditional or. So you can say this, if this condition is true and this condition is true. And you can use those double ampersand signs. But let's go back to our chapter. Alrighty. So here our author is going to tell us about division versus using a remainder. And our order of operations are parentheses. Parentheses are very important. And here they break out an algebraic equation and the Java equivalent of that. And so this is where these parentheses really come in handy. So m equals, and then we know that what's on the top line should be in parentheses because all that should be evaluated together. That whole thing divided by 5. If we had a plus b plus c plus d plus e divided by 5, that would be different. And I won't go through the calculation of a polynomial because the author has done an excellent job on that one. So decision making and conditions. Well, now that we have some operators, what can we do with them? One of the things we can do is we can say, is this equal to that? And here's a really good point. A equals B is not the same syntax as A equals B. Equals as an assignment, equals is what's called an equivalency. So if I want to compare two numbers together, if number 1 equals number 2, I would say if number 1 equals number 2. If I've done this in my program before, if I say number 1 equals number 2, then that's always going to evaluate true, and number 1's value is going to be mutated. It's going to be changed, and it's going to be set to the value number 2, and it was not what I intended for it to do. So I strongly encourage you to go playing around with some of these mathematical concepts. The nice thing is that the computer does all of the math. All right, and let's see, what else? We have precedence associating left to right. And that's it for Chapter 2. We've dived into our first class. We've used system.out to output some text as well as formatted text. And then we've dived into some mathematical things so that we can add and subtract and multiply. Chapter 3. Now we go on to classes, objects, methods, and strings. So I've mentioned some of these things earlier and you've seen them, but now we're going to dive into what exactly is a class and how is a class different than an object. So in this example, we have this class called Gradebook. And so Gradebook here maps to a concept that we have, a physical thing called a gradebook. And we're going to conceptually design a gradebook all in the ether, no physical pieces of paper. So the first class that they've added is display message. And so this is really handy because when we go and instantiate a gradebook, that means we do new gradebook, we've created a new piece of memory. We've said on a chip here, there's some memory, go carve out this little space, and this is where our gradebook object is going to go. Now I'm going to call that display message. And so this concept right here is very important. It's kind of like the heart of object-oriented programming, because what we've done is we've associated this piece of code, display message, with this class gradebook. Other classes can also have a display message, and I might choose to do that because it's a great name. But if I say my gradebook, which is my particular instance of this class gradebook, meaning it's my object, tell me how to display your message. The author again goes to create a new class called Gradebook Test. And going back here, this is, call it like the holder program. It's the outer wrapping program. You can see I have a rabbit here. I really do have a rabbit in my hat. And this is a program meant to exercise our class. Down here at the bottom of my page, but in your book, here's the most simplest UML class diagram, and we're going to be using these so that we can visualize what this class is. All these concepts here are very abstract. Program is a very abstract thing, so anything we can do to help make something more concrete, to make it readable, visible, is what we'll do. So this little box right here says, okay, I'm a class, and the plus sign says, okay, I have a message, and it's public, and it's called display message. Now let's say we want to call a method and we want to add a parameter. We're going to pass some data into it. And so here now we have display message, but now we're going to pass in the name of a course. And so we have public, meaning that other things outside of this class can call it. So our gradebook test can call this method. Void, it doesn't return anything. Display message is a method name. And so now string, which is a type, course name is the name of the argument. So we now have system out printf, and it's going to print the course name. And we can say, oh, it's printf. Okay, so that's formatted print. So that's why we can do this %s. And it will substitute course name, the value that we passed in that sentence, welcome to the gradebook for course name. And in our test, our author has done a println, so please enter the course name. And then now we have a scanner, and this time our scanner is reading text input instead of numeric input. And they've updated our UML so that display message now shows that it has a string parameter. Instance variables, getters, and setters. Here's another key concept. So gradebook can have what's called an instance variable. It can have information that's associated with that gradebook. For instance, here it's what course is this gradebook associated with? Because I could go do new gradebook for 5 different courses, and the object needs to have some identifying information. And so here it's the course name. So we have this variable here, and there's the word private instead of the word public. Private means that it's scoped to that class. So gradebook test cannot access the course name. Thou shalt only access the course name through the getters and setters. And that's what we mean right here by set course name and get course name. So it may seem a little redundant of why do I have to have these methods that simply return back the name and accept the name? Why can't I just go to the property directly? Well, when you get into larger systems and systems management, you don't want other programs or other pieces of your program to be dependent upon your implementation. So let's say here that we wanted to store the course name as two different strings. Maybe it was a beginning of the prefix and a postfix, or maybe it's a number like IT 5303 and the name of the course. Maybe all of those are part of the course name. Well, we don't want the outside of the world to know about that. So we would encapsulate that inside our getters and setters. Encapsulation and scoping is very important in application development. And here our author goes into a little more about public and private, called an access modifier, our getters and setters, and our display message. And as you can see, the UML diagram has been updated. So now we have minus, that means private variable course name is a string, and then plus is public, so we have set course name, get course name, and display message. Another example would be, let's say I always wanted to display the course name in uppercase. But maybe I stored it as mixed case or however it came in. So whenever you said get course name, I would uppercase that course name before I returned it out to you. In some way you can think of hooking these, they're like little spigots that you hook up together. Now we get into variables and typing. So primitive types and reference types, or one might could say object types. So primitive types are int, char, float, double, byte, I believe they are. Those are things that they're not objects. They occupy one little piece of memory, and they don't involve pointers, which we'll talk about in just a little bit. Reference types are things like a string with a capital S. You'll find reference types in, for instance, like java.lang.string. Reference types have methods associated with them. So a string can have like a toUpper function, whereas a basic type like an int is just an int. There's no dot operator that can work on that type. Now our author goes on to initialization with constructors. And so gradebook equals new gradebook, and now they're passing in the entire course title. And so when he creates the new gradebook, he's setting the course name. So he doesn't have to explicitly call set course name later. As a matter of style, he has said, well, course name equals name. If you wanted to be really strict about it, you would say, no, 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 you have to go through the setter. So I might say this dot set course name is course name. That's splitting hairs a little bit. In this example, the author has created several gradebooks. And so when they were created, he's saying you're this course and you're that course. And so now when you call gradebook get course name, or he could also have called display message, then now we know which object we happen to have. And now we've updated the UML diagram, and we have a constructor. And so constructor, we don't call it constructor in the method name, but because the method has the same name as the class, that means it is a constructor. And you can have several different constructors, and they can take multiple parameters. And this is, what is this called? It's operation overloading. So moving on into some more data types, floating point, type, numbers, and double. So this is where it's interesting to know about how much memory is required to hold a particular piece of information, and that how much memory is used is related directly to how much information it can store. So let's go take a look at Appendix D. And so a Boolean is just a true-false, just two values. A car can hold, it's 16 bits, and so it can hold 0 to, what is it, 65,535. So there's that many unique characters. Let's move on to an int. So an int is 32 bits, and a long is 64 bits. And I will not try to even pronounce this. But what you have is an int range is -2 to 31 to 2 to 31 minus 1. You might say, where's the minus 1? Well, we have to have this concept of 0 somewhere. A long is much bigger. It's -2 to the 63 to 2 to the 63 minus 1. So one has a bucket that's this big, and the other one has a bucket that's this big. And this means that you can hold a bigger number. I don't know if you remember the very old movie, well, like 1980s, where, oh gosh, I think it had Eddie Murphy in it, and they make their money by this rounding error in the bank. So when you get into a float and double, you can think about that. So again, a float is 32-bit and a double is 64-bit. You may have thought when you bought a computer, maybe like 5 years ago, you would have to choose between a 32-bit computer and a 64-bit computer. Well, that refers to the kind of like memory instruction set, word size, kind of put all those words together. And literally, it's like how big of a bucket the CPU has. If the bucket has, if the CPU has a bucket that's, let's say, 32 inches tall, then it can hold so much information and shove it over here. But if your bucket is twice as big, it's 64 inches, then you can literally move more stuff in your bit mine from one side of the CPU chip to the other. And so that's why a 32-bit computer is inherently faster than a 64-bit computer. All right, so our author has switched from our gradebook to an account. And so a bank account, we all understand that. We love to have big numbers in our bank account. And so here we now have a class account, and it has a balance that's stored as a double. What was a double? Let's see. There's float and a double. So float is single precision floating point, and a double is double precision floating point. So we have is stored as a double, and whenever we can create an account, we can pass in an initial balance, and it is of type double also. And so we can say if initial balance is greater than 0, then balance equals initial balance. And by default, the value has 0. In Java, for instance, primitive types, you don't need to initialize to set to 0. By default, they are at 0. And then here we have a method public void credit. So this is adding to your balance, and then get balance is returning the balance. Moving on, now the author has this kind of program that tests everything out like we've seen before, the structure, because it's in public static void main. So this is what's going to execute when the program is executed. All right, then we're going to create 2 accounts. We're going to print out the balance. And we're using that printf again. And so now we have a $sign. It's going to print $%.2f. And so .2 means 2 decimals after 2 positions after the decimal point. And we're going to accept some input, and we're going to go and stick that into your account. Woohoo! All right. And now we're going to see, okay, how much is in there, and we're going to track that information. So you can see how now our class account has some information that's being mutated. Before we had a gradebook, we created the name when we instantiated, but now our account is holding something. It's doing something. And so here we have our UML diagram. So it says, all right, I have a balance, and it's of type double. I have a constructor, and I have 2 methods. So think ahead to how I might ask some questions of, oh, I might give you a UML diagram and ask you to implement those classes, or I might ask you to tell me about this program based upon this UML diagram. Now, we're going to skip all the graphical user interface pieces here because this is a beginning course, and that's something I consider a bit beyond the scope of where we're at right now. And that is the end of Chapter 3.